Good day, students. Today we're going to look at the solution to number 3. It's on page 114 of book 2, book 1, chapter 2. And it's asking us to solve a system of equations by graphing. So the first thing we're going to have to do is graph each line. So let's look at the first line, x minus 2y equals 10. And let's isolate the y, finding the slope and y-intercept. That's the method I'll use. Slope y-intercept method. You could also use 2-intercept method for graphing, but I'll use the slope y-intercept. So the first thing we do is move x over to this side, of course, giving us minus x, right, plus 10. Now, to isolate y, we must divide each term by the coefficient of the y term, which is negative 2. So we'll divide each one by negative 2, giving us y equals, because our x's are negative 2's cancel, y equals, now it's understood to be a negative 1 there, so it's 1 over 2, negative over negative is positive, x, and positive 10 divided by negative 2, of course, is negative 5. Which means our slope, which is the coefficient of the x term when it's in this form, we'll call it m1, is equal to a half, and the y-intercept is the number left over there, so b1 is equal to negative 5. Now we'll plot this line right away, and the first thing you do when plotting a line, of course, is always start with the y-intercept. So you start here, find that point on the y-axis. That's what a y-intercept means. Point on where it crosses the y-axis. So from there, use our slope, and our slope is 1 over 2. That means our rise is 1, right, and our run is the bottom, the denominator, 2. So we rise 1. It's a positive slope, so go to the right 2. Rise 1, run 2, or go down 1 and run to the left 2. Same line. Okay, let's graph that line now right away. And let's see what that line looks like. So there it is right there. So there's our first line. Of course, the next thing we do is take the second equation and repeat that process. So the second equation is 3x minus y equals 0. Isolating y once again. Bring the 3x over to the other side. It becomes negative. I'll leave the 0 there just to make sure we don't forget the y-intercept is going to be 0 in this case. Now divide everything by the coefficient of y. Now the coefficient of y is understood to be, a negative y is understood to be negative 1. Now you could also just change the sign on every term, or you can multiply through by negative 1. Each of those methods work. But I'll divide through by negative 1. Now negative over negative leaves us with a positive 3 over 1 slope, and 0 divided by anything, of course, remains to be 0. This indicates to us that the second slope, okay, we'll call it m2, the slope of this line is positive as well, 3 over 1, and the y-intercept is 0. Again, your starting point is always the y-intercept, which of course will be the origin this time. Now we have a positive slope, so again we're going to rise 3, 1, 2, 3, run 1, rise 3, run 1, which is the same as going down 3 and running 1 the other way. Okay, so there's our other line. So let's draw that one now as well. So here's line 2 right here. Now the point where they intersect is of course the solution to the system, and that's what we're interested in, the point where they intersect. Now let's look at that point. Okay, so that point right now looks to be right there. Now we have to read that from the graph. Okay, so if we're reading that point, in other words, we want the x coordinate and the y coordinate, right? X is always first, and that's, so we go up to read the coordinate on the x-axis, and it looks to be negative 2. So our x is negative 2, and we go across to the y coordinate. It looks like x is negative 6. So it looks like our solution is negative 2, negative 6. Now, in order to to verify that, of course, the best thing to do is check it. Now, how do we check these? Always go back to your original equations and substitute in. So we're going to see now, I'll put a little question mark over the equal sign. When I substitute in x, which is -2, and I substitute in y, which is -6, are both sides of my equation the same number? -2, now -2 times -6 gives us a +12. And as you can see, -2 plus 12 is 10. So 10 equals 10. Therefore, that works. Now, with a system of equations, you may have made one sign mistake somewhere, and still have a solution that works in one equation and not the other. So you must check both. So check both equations. Okay. So we'll check the second equation right here. 3x minus y is equal to 0. Again, x is -2, y is -6. Be careful, there's already a negative sign there in front of the y, so it's minus a -6. So -3 times -2 is -6, minus a -6 is +6. So 0 does equal 0, so we have indeed found the correct solution. Right? So the answer to our final solution to this, of course, is -2, -6. And you can leave your answer as an ordered pair. So that's the solution to number 3 on page 114.